Okay, now that we got the top of this milled off, we're ready to go ahead and move on to this area of the dynamic jaw. We want to get this milled machined so that our jaw right here that bolts on will fit. So we have some material that we got to take off this area here. The back, it's got to be milled, and there's also a step that gets machined into that there. It's clearance for this part of the jaw. So what we want is the jaw to kind of rest on this surface and then of course pull back on that face right there. And it'll be just up to this edge right there if we get it machined properly there. All right. I have got a solid carbide fine pitch roughing end mill mounted in our collet holder, and we got just enough clearance to do this. We got the table all the way down as far as it'll go, and I've got the cutter up in there a little bit further than I want to, but it's still clamped in there good in the collet. So this cutter right here should work perfect for what we're going to do on our vise here. So let's go ahead and we'll get a measurement here. Now that we got this milled, we'll be able to set our height gauge right here and use that to just measure this step right here or this distance that we want to make sure that that's machined to. Okay, we've got our handy dandy height gauge here, our digital height gauge. I absolutely love this tool, man. It makes measurements like this just so quick and simple and easy. All right, so let's go ahead and check our zero, see if we're still zeroed out on the very bottom there. That looks good. It says a half a thou, but I'm just going to call that 0 there. All right, so we'll bring her up and let's come in here. There's a crest or a crown right there in the middle from the parting line. We'll just measure that since that looks like that's the highest point. 3 inches, 68 thousandths, okay? And the dimension from here to where this is going to be finished machined is 2 7/8, so that's telling us that we've got 3/16 of an inch to come off of this ledge right there. So we'll get the cutter touched off, I don't know, take about half of that or whatever, and get a nice flat cut established across there, cut the back, and then we should be able to just make some finishing passes across there to finish it out. There's no dimensions to follow as far as how far back this shoulder is going to be, but there is a dimension that's on the front side here because this is supposed to be machined as well, and it gives you a dimension from here to here, and you also have an overall length there. But as far as this goes right here, the distance from this area here to this area here is 0.8 inches. So we'll make sure that we machine this to the same specifications that we did on the main vise body there as well. Okay, we've touched off in both Z and X. We've got a cut established that we can go ahead and take. I thought I'd show you some parameters for the machine settings. So I was figuring on this cutter, we're cutting cast iron as 150 surface feet a minute is a good medium. Anywhere from 125 to 200 is kind of a good range for cast iron using carbide tools, by the way. So if we would set it at 150 surface feet a minute, we'd be at 573 RPM. The closest setting I have without going over that is 527 RPM on the machine. So that's 138 surface feet a minute. All right, and then as far as the feed rate goes, this is what I calculated that it wants for feed per tooth, cutting cast iron, 10 thousandths feet per tooth. So you take that, multiply it by the number of cutting teeth you have. We have 5, and then multiply that by your RPM that you're running, 527. That equals 26 inches per minute. Now I am not going to feed that cutter at 26 inches a minute. I mean, that is just ridiculously fast. And when you're doing setups like this, you definitely don't want to cause a crash or potentially move it in some way. So we're going to slow that down and take our time and probably use a very conservative feed rate across there of maybe about 5 inches a minute. All right. All right, that cut went buttery smooth. I love it. One of the great benefits of the Kearny Trecker is how much mass and rigidity it has when you're using it for end mills like this. I want to see where we're at on our first cut there. I'm going to do this much like I did the main body. We're using this just to rough it out really close. I'm going to swap that out with a different end mill so we can get a better finish and make sure we cut all the way in that corner. So let's just take one more cut here. Let's see where we're at. 2" 949. I'm going to just do a little bit of math right here. 2.949 minus 2.875 gives us 74 thousandths. You know, so we'll take another 62, be a 1/16 of an inch. That'll give us just enough to clean off the bottom right there and bring it to size. While we're at it, we're going to go ahead and take another 50 thousandths off the back side of that too. All right, so we got our height gauge on there. We're reading 2.887, so that gives us 12 thousandths to bring it down to a spec. So we'll go ahead and find a different end mill, get rid of that roughing end mill. That way we can finish this out, have a nice smooth finish on there. We'll clean up the bottom and the back. And when we make that pass across there, we'll lower the knee down so we can come in and cut this step in one pass there as well. I found a really nice 1.5" end mill there, 6 fluter. It feels like it's brand new, so it's nice and sharp. So we'll go ahead and get it touched off. I'm going to use the piece of paper trick to establish where our flutes are. So hold the paper very lightly and just run the part up. Now it's going to cut at the bottom, but we want to touch the side, and it should just pull that paper through my fingers when we get it up there. Just like that, okay? That'll be our X dimension, plus maybe about 2 thousandths. All right, so I'm going to do the same thing with our Z. Move that one out of there. I'm going to get it up real close by sight. And then, see if we can get this guy in there. It's going to be really tricky. Let's see if I can do it from this side here. Got to have something without corners sticking up. Let's try that. All right, it's trying to cut it there, so that should be our Z. Let's make our cut. We're running at 168 RPM, running approximately a 60 surface feet per minute, and we're going to use our same feed rate of 5 inches a minute. All right, once again, we got a nice smooth cut. No ringing, no chatter. Gotta love the rigidity of these old milling machines. All right, let's check our height, see where we landed. .8745, half a thousandths. .874.5. So I'd say we're within a half a thousandths of our target. The print actually says 2.873, so I was rounding up to 875 and kind of giving myself about a 2/1000th tolerance to fall within. So I'd say that that's plenty good. So that's going to be finished up there. What we're going to do is set a 0 since we've cut the bottom where we want it, and we'll move this up. I got to look at the print. I want to say it's 1.3, but we'll drop the knee down so that we'll get to the bottom of this step where it needs to be and go ahead and cut that next. Got the DRO on 0 there. We'll come back up, we'll go past it. All right, and we can come back up. 1 5/16. There we go, 1.3. We'll make a cut and see if that's right. Okay, let's go for it. Beautiful. So everything went great, except for one thing. Did you notice what I did wrong? Here's our jaw, and it fits on there nicely. So whenever I dropped the knee down, I went to 1.3, and I showed you on the print it was 1.330. So we have a slight amount of gap right there on this step, and that's where I went wrong. Now that's not gonna break the job or anything like that. This vise is still gonna work just like it's supposed to, because all of your downward force is still on this mass area there. But it's just one of those things that you go through. I had a dimension in my head when it was actually something different, and I should have verified it again by looking at it, but I thought I had it right. But once this is bolted on there, this overhangs just a little bit. Once that's bolted on there, nobody will ever know, except for maybe you guys watching the videos here. So just a dumb mistake. Luckily it's not anything that actually scrapped the part at all, but it is kind of an embarrassing mistake to make. But I show these things to share with you guys that this kind of stuff happens, and it is embarrassing to do it and show it, but it does happen, and we all do it. So luckily it's not anything very critical. It's really just clearance there. But the way that Jason had this design, this jaw, is that it actually sets on this surface and this surface to provide a lot of support if you're using a vise in a manner where you're putting a lot of downward pressure on that. But once we get that bolted on there, nobody will ever know there's that little gap right here. But we do need to come across here and just kind of break that corner off. Since we had it down a little bit too further, we don't have to put a large bevel on there, but we do want to break that corner off and get rid of that. So we've got that to do, and I would actually like to make a cut across this surface right there, this bottom casted area. I'd like to make a clean cut just like we have on our main body. We're going to make this dimension, this width, 0.75. So on to the last step that we're going to mill. I've got it swapped out. That's a 2-inch diameter 6 flute end mill. It's not going to be a big heavy cut, but what we want to do is just machine this area right there and get that cleaned up to match the rest of the vise jaws there. So we're going to be running 115 RPM and 5 inches a minute as we go across there. We'll probably make one cut. I'm going to take a measurement and just try to hit a nominal size of 3/4 inch, and then make a second cleanup pass. A little aggressive, so I just slowed it down to 3.5 inches a minute. So during the cut, what I noticed, I could actually see the thing kind of vibrating a little bit because it was beating on those flutes because of the feed rate that I had it set at. So I ended up just dropping it down to 2 inches a minute to go across there, because we're not in a hurry and we're still making enough cut that we're not damaging the cutter by not feeding it enough there. But I can see right here, there's a little line in it where you could see the part was actually trying to bounce around the table. Everything's just trying to move because it was just feeding too hard into that. So depending on your workpiece and your machine, you have to make adjustments on your feeds, not necessarily what the book is telling you, but you got to make adjustments according to your setup and how rigid it is and everything like that. Come in here and get our measurement. We'll just use our calipers for this here. .763, 762, 762. So we'll take 12 thousandths. All right, that was our second pass across there. Another beautiful silky cut. Let's see what we landed on. I was shooting for .750. .749.5. 749.5. I'd say we hit it within a half a thousandths of our target. No big tolerance on this right here. It's really just a cosmetic cut there to make it look good, and it'll match the opposite side of the jaw there. All right, guys, well, this operation is completed, and I think this is going to wrap up this particular video or this episode. Our jaw sits on there, looks nice. So the only thing we got left to do right there is to come in here. We've still got to drill and tap our 2 half-13 holes. We're going to get to that later. We may even use the horizontal mill right here to take care of that, because this is going to be a little bit of a challenge. I do not have a right angle head to fit the turret style mills, so we may end up setting it right here on this table and using our horizontal spindle with some long cutters to come in there and drill and tap those 2 holes. But we're going to get to that later. That'll be a separate video later on, because what I want to do is move on now and finish the machining of the ends of this guy. We still got to finish the 2 sides. We already talked about that. But when we were shaping the sides of this, I had talked about I wasn't going to worry about cutting the end of this. But since then, I've decided I think I would like to go ahead and cut this and this other face right here, because this is supposed to be machined as well. Do both of those on the shaper using our automatic down feed. I think that would be a fun video to make and show you how to use the shaper to cut the sides in right there. I was going to show you. So there's the print, and you can see you actually have a dimension 28.577 inches from end to end, and then we have a dimension from the end of the jaw to that step that we machined in there as well. So we got a couple dimensions that we can work off of. And as far as the tapped holes, we go to this print right here, and you can see it gives you all the dimensions there for the tapped holes that we'll come back to and visit that later on. But I would like to continue getting the rest of this machined and completed. And the last step will probably be drilling and tapping those holes, and then this guy will be ready for assembly. So we'll bring you back. I think I'm going to move over to the shaper, and let's use that to cut the ends and have a little bit more fun with our shaper on this Hardtail Vise build.